Hello, everyone, and thanks for coming to this talk about a fun little project that we built at LlamaIndex using all of the LlamaIndex tooling. And this whole presentation is mainly going to be me explaining to you how we built it, the challenges we set ourselves. So it's kind of like a demo show and tell rather than me explaining all of the LlamaIndex tools and products we have out there. But before I dive into that, my name is Tuana. I am based out of Amsterdam, and I have been working with LlamaIndex for the past about 6 months, and I'm in the developer relations team. I was not supposed to be the one giving this talk. It was quite last minute, so I hope you enjoy. But I have given a variation of this, so I think it should all go quite smoothly. Although I've done a lot of talks in the past, I am still terrified of live demos, so there will be a live demo, but it's already running, and I will not be pressing play as we go along. You'll already see something that I've ran just a few moments ago. All right, so what did we build? NotebookLM. How many people here knows about NotebookLM already? Okay, actually quite a few, way more than the last time I gave this talk. So for those of you who don't know, I'll give you a very quick introduction into NotebookLM. And this whole presentation, like I said, it's kind of like a demo show and tell, but it really boils down to us looking at NotebookLM, saying, this is cool, and we work at LlamaIndex, we can build the same. And realistically, what kind of abstractions would we need? And how can we make our lives a bit more difficult and build something cool? All right, so for those of you who don't know what NotebookLM is, it is a great little tool by, not little, actually quite a big tool by Google. And it's what you see here. It's a screenshot of NotebookLM. It's pretty cool. You can connect it up to maybe your Google Drive, drop in some URLs, you can provide some documents you might have, and then you can do a lot with those things that you've provided in NotebookLM. You can have it produce a podcast based on the content. You can do document QA based on the content. Just a whole list of things, and one of our favorite things that you can do with your documentation is, okay, so this is what you get at the get-go. Maybe you upload a file about something in this case, and we'll be looking at this particular example in a bit as well. This is a IKEA kitchen building guide, I think from 2021 or something. And this is me uploading that PDF and having a conversation about how I might get started building an IKEA kitchen. And another thing you can do is build these really cool looking mind maps. And mind maps are interesting. They're kind of a nice way to visualize and abstract information that might be present in your documentation or your file that you uploaded. And in this case, the mind map that NotebookLM created is this sort of explanation as to what the guide includes, the various steps in the guide, and so on. So that's the challenge we set ourselves, that how can we build something? We work at LlamaIndex, we have many tools that could help us build this. How could we do it? And also, we set a few other challenges for ourselves, and that was the following. We wanted to be able to basically build a NotebookLM. I'm not going to call it clone, let's call it a duplicate. We wanted to build a NotebookLM that would be able to handle pretty complex file types. So we wanted to make sure it would handle tables, PDFs with images and figures in them, and also what I like to call layout bonanza, especially if you have, maybe you're expecting a certain type of file, let's say, I don't know, invoices, but you want to be able to handle invoices that may come in a whole slew of different layouts, and it shouldn't matter. The next thing we wanted to do, and I think this is the main thing that we built really, is we wanted to make it so that we would open source this project and it would have reusable components. So anything that we built for our own, let's call it NotebookLlama from now on, we wanted to make sure that you could reuse each and every pieces of the tools that we built yourselves. Finally, we wanted some level of control over the flow, and especially if you are building agents yourselves or you're not new to agentic AI, this is pretty important. We wanted to make sure that we weren't building an agentic application that would just run anything at any time and leave all of the decision to the large language model. We wanted a level of control over how the notebook is built, how the mind map is built, when certain things happen in the first place. So those were the challenges we set ourselves, and this is where, obviously, I'm paid by my company to talk here, so I'm going to give you a quick introduction into the various products we have at LlamaIndex, and hopefully you can already start imagining which ones we used, why. So LlamaIndex is, I would say, best known for our open source framework, which is itself called LlamaIndex as well. And this is where you can orchestrate your own agentic AI applications. And when I say that, I mean really you're the designer of the type of agents you're building. So that's the middle layer that you're seeing here. This is the agentic framework, and the main product that we launched the first version of recently here is called LlamaIndex Workflows, and that's going to be the basis of our own architecture as well. And I'll show you how we built our own Llama agent workflow that is able to create our own notebook. The second thing we have at LlamaIndex is a platform called Llama Cloud. And Llama Cloud has a few tools, mainly centered around document agents. So we have Llama Parse that is able to parse complex layout documents. We have Llama Extract. We get a lot of confusion about the difference between extract and parse. We can talk about that later as well. But extract really is a tool that we have that is designed to extract specific fields and information out of our document. And then we have various other tools like Llama Cloud Index, but parse and extract is going to be the two that I focus on because they're going to help us achieve those first two challenges that we set ourselves. So what does parse do? Well, it does the following. You can imagine, for example, a document like you see at the top here, where you may have different images, figures, inconsistent layout throughout, and it allows us to basically take all that information and this is the key, I would say, approach the layout itself as context that's relevant to the LLM as well, and use that to transform that into context that an LLM can actually work with, whether that's Markdown or something that's encoding the layout information as well. And extract is what you see maybe on the bottom. I know it's quite blurry, but that is, and I'll show you an example in a bit, is the NVIDIA SEC filing report. It has a lot of information in there, and extract is a way for us to basically define the few fields that we are really interested in, and then create an extraction agent based off of those fields and get that information out of our pretty long SEC filing report. So that's exactly what we've done here. This is just an example of the NVIDIA SEC filing. On the right-hand side here, you see the extraction result, which is showing you the various fields and the values for those fields based on the information in our file. So the way you configure an extraction agent, which happens in Llama Cloud, you have a few options. One, you can go ahead and select one of the predefined templates in Llama Cloud UI. We already have the 10K filing here, for example. Or, which is slightly more fun, and I definitely prefer doing this myself, you go ahead and create a Pydantic schema. And you say, here are all the fields that I want out of my very long document. So here you see me defining a schema called financial report. And most importantly, we are also giving some descriptions as to what those fields are. These descriptions are super important because it gives the LLM an idea as to what it should be looking for in the document and what should be assigned to this particular field. And then it's pretty simple. You go ahead and create an extraction agent, and then you funnel your files through this extraction agent and wait for a response. So back to NotebookLlama. From now on, I'm going to call it NotebookLlama. Maybe you already remember seeing this when I first showed you the NotebookLM screenshot, but you get quite a lot of things. Once you've uploaded a document, you get Q&A environments, you get a mind map. You also get, which I didn't show in the screenshot, but I'm going to show you in our own NotebookLlama now. You also get some simple FAQ questions about your document, a summary about your document, and so on. So the first thing we did is actually make use of our very own Llama extract. You can see here that I have started to create a schema. It has a summary, highlights, questions, and answers. So this is the first entry point to our NotebookLlama workflow. Next, we started to design Llama extract into a full NotebookLM creation workflow itself. But before I get into that, I'm going to quickly go here and show you an example. So like I said, I'm not going to run this live, but hopefully we can have a quick look. So I uploaded the same exact IKEA kitchen guide as you saw before to our very own NotebookLlama. So this is what you get with our open source project. You can run it yourself, and it's a very simple Streamlit app. But once you've uploaded it, you already get a few things. You have a summary, you have bullet points, you have a mind map, you have FAQ questions, and then you can go ahead and chat. You can maybe do some observability over how long each query is taking, and so on. Now, if I were to switch over to Llama Cloud, you see here that I am in Llama Extract, and let's have a quick look as to when I first uploaded the file, what happened. So it's a temporary file, so the file is not loading. I pretended to do the whole thing and uploaded the file myself to Llama Extract, so you can have a look at it if you like. But here you see the extraction results. So that was the IKEA kitchen guide, and what we've got is summary, highlights, questions, and answers, exactly as you are seeing over here. So the first thing that happened is we send our document gets parsed, and the various fields extracted by Llama Extract, and then we populate this initial page that you see. How does that happen? Well, we use the LlamaIndex Workflows framework. This is going to be a quick introduction to LlamaIndex Workflows. You can make them as simple or complicated as you wish or need to. But the very short summary is that it's an open source framework. It's in Python, but you can also use it in TypeScript. It's event-driven, and you'll see what event-driven means in just a moment. It means that it's also composable, very customizable. And given the event-driven architecture, it's actually pretty easy to debug because you can actually just go ahead and debug each step that you've carefully curated yourself. Before I dive into the actual design of the workflow, I need to shout out my colleague, Clelia, here. This is mainly her brainchild. She did a lot of work here, and I think feel like I'm mainly representing her work at this point in time. So if you do want to follow her, that's her. She does amazing demos and projects with LlamaIndex. So the few things that we set off with is obviously we weren't aiming to build the entire NotebookLM application ourselves, but we did have a few requirements. We wanted to make it fully open source, and once a user uploads files, we wanted to make it so that it generates a mind map, similar to the way you've seen in actual NotebookLM. We wanted to have some sort of Q&A so the user can ask questions about the document they uploaded. We wanted to make sure that tables and images were handled. And we also, and this is an addition that we made very later, very down the line, and I'm not going to be showing it, but we did want to have podcasts and observability. So those were the two extras we added after our first release of NotebookLlama. All right, so this is the entire architecture of our final NotebookLlama. And one thing that I want to already point out that I haven't mentioned at all, but at the beginning, I already said that we definitely wanted every bit of the workflow that we built to be reusable in isolation to the workflow itself. So pretty early on, we made the decision to make it so that any tooling or functionality we were providing to our workflow itself would be an MCP tool running in its own MCP server that you can decide to use in a completely different project yourself if you wish to. So our MCP server has three things. I know we're showing only two, but the document processing bit where we do the extraction of the highlights, Q&A, summary, etc. The mind map generation is yet another MCP tool that you can use in isolation. And on top of that, the document Q&A is also a separate MCP tool you can use in isolation. So let's focus on the initial notebook creation workflow and how we created that. This is a very, very simple high-level overview of each step that we wanted to take. User uploads PDF, a mind map is generated from the PDF, and a final notebook is created with the mind map itself on top of all of the FAQs, highlights, summaries, and so on. This brings me to workflows. I already mentioned that workflows are an event-driven architecture. What you're seeing on the screen is a perfectly valid LlamaIndex workflow. It has two main components, I would say, are abstractions, which are steps, and they are simply functions that have the step decorator, and events. Here you see 3 steps, and for example, step 1 is expecting the start event. This means that whenever the start event is emitted from elsewhere in the workflow, step 1 is triggered. Step 1 is emitting something called first event. So if I were to draw this out, which you can do with LlamaIndex, this is basically what our workflow architecture looks like. We have step 1, step 2, and step 3. So what we wanted to build, and I actually just printed it out earlier, and like I said, you can visualize these workflows yourself. We wanted to create our very own workflow with our custom start event called file input event, which would then go to the extract file data step, which would emit 2 separate events, mind map creation and notebook output. The mind map creation event generates the mind map, and then we have our final notebook creation step at the end. All right, so for that reason, I kind of showed you what steps look like, but I didn't really mention what events look like. Events are, again, fully customizable, and they're basically a way for us to funnel data from one step to the other. So in our case, we created 3 main steps to build our NotebookLM. File input, which is only providing the file string. Notebook output, and mind map creation. All right, so here you see our NotebookLM workflow with our first step, which is expecting the file input event, which is the step called extract file data. And this is exactly where I want to show you and make sure that you see that the MCP client is the main thing we're calling here. So we, in the background, have an MCP server running with 3 separate tools. And the first of those tools is called the process file tool. And this is where we are calling our extraction agent that you saw earlier. We're waiting for a response with various summary, highlights, question, and answers. Next, we have our mind map generator. So this is our step that's expecting the mind map creation event, which is something that we return from the previous step. If everything goes well, we don't have any errors, then we trigger a mind map creation event. This is a fully custom-built mind map creator by Clelia again, and in itself, it's an MCP tool too. So here you'll see MCP client.callTool. Which is a tool called getMindMap. The main reason we did this, again, is to make sure that all of the components that we baked into our own NotebookLM duplicate, let's say, were reusable. So if you don't want the Streamlit application and you just want to be able to play around with the extraction agent or the mind map creation in isolation, you can simply just run the server, the MCP server, and then use those tools even with Claude if you would like to. And again, this is an example of one of the MCP tools we have. The project is open source, so there is a file in there called server. This is one of the tools you'll get there. And here is the process file tool that you saw earlier. And again, we bake this into our own workflow that we have control over. However, you can use them with regular agents that will rely on the description of the tool to decide when to run it. So here you see the MCP tool definition or description, if you will, that says this tool is useful to process files and produce summaries, question answers, and so on. So if you, again, want to just allow a large language model to decide when to run this tool, you are free to do that. The final thing we have here is, yet again, another MCP tool, is the document question answering UI that I don't think I showed you just yet. We can have a look in a moment. But this is a simple, you can think of it as a RAG tool in isolation. So once you upload your document, it gets chunked, embeddings are created, and we store them in Llama Cloud, in Llama Cloud Index. I know it's confusing, it's called Llama Cloud Index. But based off of that, you can start doing regular RAG over your document that you uploaded. And on top of the answers, you'll also get citations and reasonings as to why the answer was the provided answer. So all of this is built with not only LlamaIndex, the open source framework, but also Llama Cloud. We have obviously made some decisions ourselves creating this. For example, a lot of the answer generation is with OpenAI, but because all of that is with the open source LlamaIndex framework, you get full flexibility as to what kind of model you want to use. So you're free to switch it up to a Gemini model if you'd like to. I think this is gone. Or something else. And on top of that, the knowledge management, we are using Llama Cloud in this case. So when you start off and you upload a file, the first thing we do is process the file and index that into Llama Cloud. But you're, again, free to choose your data sync. If you want to hook that up to your own database, you're free to do that. Again, this is another one of our MCP tools that you can use in isolation. Query a Llama Cloud Index is the only description we've provided here, which is probably not enough. However, you can go ahead and upload your documents, run the server, and then start chatting with your documents via a completely different MCP client like Claude or OpenAI, if you would like to. Finally, this actually happened alongside our project. Because we decided to make all of this reusable MCP tools, we actually baked in a functionality or integration into Llama Cloud, LlamaIndex Workflows that allows you to serve LlamaIndex Workflows that are complete as their own individual MCP servers. So we created this helper function that allows you to, once a workflow is created, just say .serve as MCP server, which spins up a new MCP server that has one tool, and that is your workflow. Same way, we've also done the same for all of our Llama Cloud products. Anything like extraction agents and Llama Cloud indexes, you can serve as their own MCP tools as well. And with that, I'm going to show you the QR code in a bit that should take you to the repository for NotebookLlama. Please try it out, contribute to it. It's definitely open for contributions. And it's also a great way to discover the various Llama Cloud and LlamaIndex tools because it uses literally all of them. Thank you. And I'm happy to answer any questions if there are any.
Do we have any questions for Tuana? Over here in the front row.
Great talk. I have two questions. So, like, I understand, like, from a document perspective, like, you're uploading it to the Llama Cloud. Mm-hmm. So, my question may be dumb, but, like, is there a way that we can host the NotebookLlama locally and use a local vector DB as part of it?
Definitely, yeah, sure. Like I said, we made the choice to index everything in Llama Cloud, but at the end of the day, it is using open source LlamaIndex Workflows. So instead of actually I can go back and show you exactly. So here you see I create a Llama Cloud index, and every time there is a question, I'm querying that query engine. Instead of that, you can go ahead and change the code, host it all in a local vector database, and that's it. The choice is definitely yours.
So this is good. Thanks for clarifying. The second part of the question is, Yeah, so in context of the workflow that you described, so that workflow, can that be hierarchical in the sense like right now, so you're describing a simple linear DAG in terms of
Yeah.
how the workflow is proceeding.
Yeah.
So let's say you have a scenario where you're actually building the prompts in a way where it sort of traverses across the hierarchy through the hierarchy of agents. So is there a way to compose all of that?
Yes, so there's actually two ways. One is actually pretty simple. For a moment, I'm going to ask you to ignore the actual names of these steps because it'll help me explain better. One thing that you can do, every step, although I didn't talk about it much, can actually branch out to. A single step doesn't have to emit one event. It can emit 2, 3, 4. It can also loop, which means that you can design in a sort of decision-making step in there. That can also be based on an LLM. So an LLM can decide whether we do this event now or another event now. That's one thing. The other thing is another sort of high-level abstraction we have, which we call the agent workflow, that can be given multiple agents that have access to hand over to other sub-agents or not. So you have two options.
All right. In the effort of time, we can't take any more questions, but thank you, Tuana. Appreciate you coming today. Thank you.